Good day, everyone anyone and everyone who's watching this video. My name is Lloyd Philip H. Tejada, and today I will be discussing about Bitwise and logical operator. Now, before I discuss the main topic, Bitwise and logical operator, I'll first discuss binary since it is connected to Bitwise operator. Now, binary is a base 2 system using zeros and ones, essential in computing. This is because the every computer uses the base 2 system as their language, meaning ones and zeros. So it is very important and essential in computing. Of course, since it your computers wouldn't run without this base 2 system. Now, here is how to convert a number into binary. My, as you can see in the slide, my example is 69. Now, 69 converted to binary is 1000101. And the reason for this is because these ones and zeros represent a number which is which starts from 1 to the power of 2 and up. So 1 to the power of 2 to the 2 to the power of 2, which shows 1, 2, 4, 8, 16, 32, and then 64. So the method to converting 69 into binary is to add up these numbers so that it can turn into 69. Now, as you can see here, 1 for 1 and then 0 for 2 and then another one for 4, zeros on 8, 16, and 32, and 1 for 64. These ones represent the numbers that we are adding to create 69. So 64 plus 4 and plus 1 equals to 69, which is how this 69 is converted into binary. Since we now have a basic understanding of the numbers and their binary conversion, let us now move on to bitwise operators. There are two bitwise operators, bitwise and bitwise OR. We're gonna start with bitwise AND. Now, bitwise AND copies a bit to the result if it exists in both operands. Now, what do I mean by this? Well, well, I'll show you in just a few. Now, I'll first start with the symbol of the bitwise AND, which is AND. Now, an example will be 69 and 74. 69 bitwise AND 64. Now, the result of that, ah, sorry, I mean 69 and 74. Now, the result is 64 or 1000000. Now, the reason for this is because as I said earlier, binary AND copies a bit to the result if it exists in both operands. This shows in how it is showed in the solving below. So 1000101, which stands for the number 69, then 1001010, which stands for the number 74. Now, since the bitwise AND only only copies a bit to the result if both operands have the same number, I mean if it exists rather in both operands, well, it's easier to just say to just show you. So here in adding this operation, adding I mean solving this one. Okay, let's start with the first number, 1 and 1. So since it exists in both binaries of 69 and 74, then it's 1, then 0. Okay, copy that, and 0. But in the next one, though, in the fourth line is 0 and 1. Now, since it 1 exists in 74, but 1 doesn't exist in 69, so that means it doesn't copy it, because in bitwise AND it needs to exist in both operands. So 0, and then after that 1, and then 0, and then it results to 0, 0, 1, results to 0, and then 1, 1 and 0 results to 0. This is the reason why the result is 1, 0, 0, 0, 0, 0, 0, or as a number is 64. Okay, since we're done with bitwise AND, let's continue on to bitwise OR. Now, bitwise OR, on the other hand, it only needs it only needs the it only needs the bit to exist in one operand for it to copy it, not unlike bitwise AND that needs both operands to exist, both operands to have a bit that exists. Okay, so the symbol is this line for the bitwise OR. Example again, 69 or 74. And the result of that is 79 or 1001111. Same 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 binary conversion as last time, but the results are different. See, we'll start again with the first number, which is 1, 1 and 1, which results in 1. And then the next number after that is 0 and 0, which results 0, 0, 0, then 0. But here in the fourth line, 0 and 1, it results into a 1, because in bitwise OR, it only requires for one bit to exist in either operand for it to be copied. Then in the next line, 1, 0 equals to 1, 0, 1 equals to 1, and 0 and 1 and 0 equals to 1, resulting in 1001111, or 79. Since we're done with the bitwise operators, let's now continue on to the logical operators. First of these logical operators is the logical AND. Now, logical AND symbol is two AND signs placed together. Now, in logical AND, if both the operands are non-zero, then the condition becomes true. And that means if both if both of the operands are true, then the condition becomes true. If any one of them is false, then it becomes false. As you can see in the example, in A is false, B is true. When you when you when you use the logical AND in A and B, A logical AND B, it turns into false, because there is one operand that is non-zero, while the other operand is zero, which is false. Now, in the second example, A is true while B is also true, and A logical AND B equals true, since both are non-zero, both are true, and it equals true. Now, the next logical operator is OR. Logical operator OR only asks for one non-zero in its operands for it to be true. So if any of them are true, even if the other is false, then it results to true. It shows in the first example, which shows A being false again, B being true, and it results in A logical OR B equals true. In the second example, both A and B are false. Uh, this is logical. This is supposed to be. I'm sorry. This is a mistake on my part. This is supposed to be false since both of the operands A and B are false, meaning in logical OR it is false since there isn't any non-zeros in the operands. So my bad. A and B in the second example is false. Now the last logical operator is logical not. Symbol of this logical not is an exclamation mark. Now, what logical not does, it reverses the result of any operand or condition. So as you can see here, A in the A69 is greater than 74, which is false, right? That's false. But with the logical not, it turns the false operand into true. Same as B, which is true, turns it into false. And if and in the condition A logical or B, which is supposed to be true, but with the logical not, turns it to false. And same as in the second example, an A, which is false, turns it into true, and B, which is also false, turns it true. And the logical or operation in the A and B, uh, which is, as I said before, in the logical or, which is supposed to be false since both A and B is false, it's supposed to turn into true, but here it's turns into false. So my bad again. Sorry for the very poor, poorly thought out slides. Yeah, I just did this just now, and that is the end of my short, not so short discussion. It's now 12 minutes. Thank you for watching and have a good day.